G'day, today I'm going to be talking about the charging system on my Volvo 145. So from factory, this car had a 35 amp alternator. I have since upgraded to a 100 amp alternator out of a Volvo 940, so a later model Volvo. Just bolts basically just straight on with a few spacers and washers and whatnot. In terms of other hardware I fitted to the car as part of this, so increased the size of some of the connectors and the wires that connect the battery and the engine to the alternator, and sort of better grounding and whatnot. So in this video I'm going to go through why I did it, what I found out, and why I decided on a 100 amp alternator and why this one fits so well. Righto, so when you're trying to work out how big an alternator to convert your classic car to if you're changing things around, is think about what's the largest amount of energy you're likely to use at any one time. So for me, that's going to be on a cold, rainy day, idling, sitting at traffic lights with my indicator and headlights on, is pretty much the peak load I'm ever going to experience. That's going to be, going to have my headlights on, brake lights, going to have my indicators, going to have my demister, so my fan, going to have my rear demist, which is electric, going to have my wiper blades, front and rear because I've got a wagon, trying to get that car to demist nice and quick. What else am I going to have? Going to have my, perfect, so I've got wiper washer, fan, rear demist, backup lights aren't going to be on, so my instrument lights will be on. Hazards won't be on, interior lights not going to be on, glove box not going to be on, don't have an electric fuel pump, stop lamps, already mentioned that, instrument lamps, left park, and then let's just say, for discussion's sake that, my front electric fan's going as well, so E-fan is just burbling away. So with these, each of these is going to add a load to the system, and to run these all at once at a low RPM, because I'm idling away at, my 800 RPM or whatever it happens to be, and I want to be able to idle there for as long as I have to. I could be stuck in traffic, there could be a collision, I don't want to be running out of electricity. That's a really not fun way to drive a car. So alternators charge better. Well, they usually have like an optimal RPM where they're going to make 100% of what's available to them, and that might be 800, who knows what it is. So in the case of my car, one way you calculate it is based on what headlight globes you're running, what size capacity they are, or whatever it happens to be. What I'm going to do is, I've got here a list of what the fuse requirements are for each individual thing. I'm just going to assume the worst. I'm going to assume that I'm using 100% of the available fuse power in that section of the car. So, for starters, if I'm running my heater fan, my wiper washer, or my heater fan rather, that's going to be up to 16 amps. So there's 16 alone potentially. It's probably more than it would actually be, but who knows? If I'm starting and stopping it, it could surge up to 16 and be really hard on the alternator. From there, rear demist, that's another 16 amps. And factory, my car had a 35 amp alternator. So you can already see we're touching up on that, and that's two things already. So so instrument lights and my turn signal lamps, that's a maximum of 5. So that can kind of be, those two are connected, so 5 there. No worries. From there, so my stop lamps, my brake lights, that's another 5 potentially. That's right, parks. Headlights are going to be, let's see if I can find a fuse for it here. No worries, so the headlights must go through different circuits, so I have to calculate that separately. Wipers front and rear, I wonder if they're separate as well. Yeah, there's something else as well. and my E-fan's about 30 amps just by itself. So obviously 35 amp alternator is just not going to do it. If you're in a situation like this and you don't know, what your requirements are going to be, well, the wipers in this car are pretty powerful. So I'm going to assume that it's going to take. These are all pretty heavy sort of things. Let's say it takes 16. It might be more than that for both of them, but on a really high setting, because I've got 2 settings on the front ones and one on the rear. Let's say I've got 2 going, so let's just pretend that it's 16. For the purposes of this discussion, that might be okay. If I find my voltmeters dropping heaps, then I might have to revisit that when I'm using my wipers, or I have to look at the wiper motor. With respect to headlights, if you're ever in a situation where you can't work out, how much is my thing drawing, well, most bulbs will have like a wattage rated on them. So in the case of mine, I know that I have 65 watts, which is a power rating for each of my headlamps. So I've got 65 by 2, and then my Parkers, so the ones that sit just outside the headlamps, they're 10 watts each. So that's another 20 watts. And I've got my rear lights as part of the headlights, so they're another 10. So we're looking for another 20 there, watts. And so what I can do here is calculate these up. So 65 by 2, that's going to be 130 watts. So 130 plus 20, 150, 170 all up. So 170 watts. And you're saying, well, all of these other figures are in amps. These are all in amps. Oh, that obviously isn't. These are all in lamps, so in amps. So I've got these in watts. How do I get to amps from watts? It's actually really easy. So commonly we talk about a car system being 12 volts. It's actually probably in my car with the voltage regulator that I'm using, it's probably closer to 14.5. But if we assume 12 volts, that's going to calculate a larger potential amperage, and we've got a bit of safety margin then if we're using the 12 volt number instead of the 14.5 volt number. So that would be like working out the exact, to the micrometer sort of level of precision. Whereas if we run 12 volts, that's what the alternator is rated in. So the alternator, is rated in 12 volts. So if you're really thrashing the alternator, it's going to make maximum power when it's putting out a lower voltage than when it's just maxed out at, what it's capped at. So in the case of 12 volts, what we do is we grab our 170 watts for our headlights, divide that by 12, and the powers of YouTube, which of course is 14.17 amps. Great, so now we've got a headlight number as well, so we can go back to our last page. And we'll chuck that in as 14.2. Again, I prefer to round up. That way, worst thing that could possibly happen is we add up a bit too much. So from here, get all our numbers. So I've got 14.2 plus 5 plus 16, 16, 16, 5, and 30. So 1, 2, 3, 4, 5, 6, 7 numbers. All looking pretty good there. 1, 2, 3, 4, 5, 6, 7. Awesome. So if I add these up, that's going to give me my total, potential requirement for an alternator in a pretty extreme situation. So bang all these together. 14.2 plus 5 plus 16 plus 16 plus 16 plus 5 plus 30 equals 102.2 amps. And again, this is a slightly exaggerated number, and this is a really extreme situation. So for me, a 35 amp alternator, it's not going to run it. It's just not even close, not even in a million years. If I do that for a minute, the alternator's working for, another 2 minutes with no load just to refill the battery to this amount, which is just a ridiculous amount of energy for a 35 amp alternator, which is why the old one, even without this extra load, with just these other ones, which are just basically factory loads, It was just cooking it. It just burnt out, and it was working it too hard. You know, my use case was no good for it. So, and that was without the injected engine, which I was going to use in it, which would have had even higher requirements. You know, powering the computer and whatnot. Whereas with my 100 amp alternator and a really big powerful battery, it means when I'm experiencing this situation, which now is less of a problem because I'm not running a E-fan anymore, it means I've always got enough, and due to the design of the alternator with an internal regulator, it's never going to overcharge the battery. So it's going to cap out at 14.5, which I've since verified. I'm not going overboard. You know, I'm not going to, you know, I've got 102 amps of maximum, you know, special course requirement, and it's pretty unlikely that I would even get that, because that would be blowing every single fuse except for the ones that don't have fuses. So if I'm blowing every single fuse, then it's going to reduce the load anyway. Like, it's going to blow the things out that are using too much power, and it's going to reduce it back to the point where my 100 amp alternator is going to take that all day, every day. And really good quality alternator, as what's used in Volvo 940s, which are a much more energy intensive car, electric windows and more advanced electronic ignition and whatnot. So that's why I went for 100 amp alternator. It was available, and the 80 amp 240 alternator was another one I was considering, like the 240 740 Volvo alternator. So this is out of a 940 Volvo. The 240 740 style, which is common as muck, and I've got plenty of those kicking around. 80 with the E-fan was going to be less than what I wanted, because I wanted that extreme situation to be covered. And so, you know, if I had $1 million and, you know, there was a 110 amp alternator around that was going to fit the car really easily and do the job, then, you know, maybe I get 110. You know, would I spend heaps extra money for a 200 amp alternator? No, it'd just be ridiculous. Just be a ridiculous thing to spend money on, because there's no point to it. It's not going to ever, you know, even get used. The exception would be if I was, you know, doing heaps and heaps and heaps of idling in these conditions, then I might find that a larger alternator, you know, because alternators have ramps as well, they have efficiencies. And so my 100 amp alternator, and what I found is, so you've got RPM, and you've got, so let's just say amperage, so the amount that the thing's putting out. So up to about, you know, I don't know exactly what the number would be, but let's call it 700 RPM. This is engine RPM. Because with the pulley system, the alternator is going to be spinning faster than the engine. But let's just say 700 RPM is the cutoff. So we're pretty much making, you know, we're bumbling along, you know, making pretty low amperage. So this isn't really a sustainable sort of scenario. Whereas, you know, a more typical RPM range, like 1,000 RPM rather. In my experience, this alternator is punching heaps of power. It'll just, if you turn it up, it's going to get to the point where it's going to stall the engine out just about. With the, like, it'll just ask for more power, and whatever it is, the design of these Denso alternators, they seem fantastic. So it must be making 70-80 amps, you know, capacity at that sort of RPM range, because it's just, I could turn everything on and the voltage just doesn't even move. It just runs perfectly. So that's meeting my requirement at 1,000 RPM, which is unreal. And it probably goes, you know, there'll be a point where it's not making any power or very low, and then it's probably going to be like that, and then probably like that or something like that. You know, it's probably just capping out what it's going to do once you hit, you know, let's say it's 2,500 RPM, 2,500. So lower RPM does reduce the ability of the alternator to make a lot of power, because, you know, the engine has to make the power that you're trying to ask of it for one, and then the alternator needs to spin at a certain rate to make that power. So there'll be an RPM where the power really drops off, and probably be like, I guess, a 0 RPM. So obviously if the engine's not moving, there's no way it could be making that much power. So that should really be a 0 point somewhere, but the 0 point will probably be slightly sooner. So probably something like that. And very low power at very low RPM, and then comes on very nicely. So usable at the idle that I've set. and then stacks for everything else. So keeps the battery topped up nicely, battery's in great nick, alternator doesn't have to work too hard for too long, which means it stays nice and cool. Ideally, I would have soft mounted it, so those alternators are designed to be soft mounted instead of hard mounted, and I've got it sort of locked directly against the engine block, whereas they do like for vibration mitigation to be soft mounted with rubber. However, I haven't done that, and it's been on there for about 7,000 Ks now. Still runs perfectly, and I'm really happy with it. And for most of that, it was running the E-fan for a lot of the time as well before I got the new radiator in the car, which has cooled things down nicely. Don't need the E-fan anymore, so it's just reduced my requirements of my charging system. However, I won't change it back because it's set up, it works. It's going to cost me money to change, and in a fairly extreme situation, it's nice to have a bit of buffer. This means I could be running all these things, idling away, and probably jumpstart someone at the same time, which would be, it's just nice to have that bit of extra, but not required. We could have done it with 80 amp alternator. Benefit of the 100 in this case is the 80 amps are like these really big chunky Bosch alternators, again internally regulated, which is again something that I wanted. I didn't want an external regulator because that's what I had previously. It's more clutter in the engine bay, didn't want it. But the 100 amp alternators, the Denso ones in the 940 Volvos, are a lot smaller space. It's going to fit in the engine bay nicely. Although for my 120 project, I'll be running an 80 amp 120 Volvo. I'm going to be running an 80 amp Bosch alternator just because I've got so many of them and really low requirements in that car. Although I may be running a electric fan in that one as well. And it had a generator on it, which is different to an alternator. They work really, really poorly at low RPM, and it's like a 20 amp generator, and they suck a lot of power out of the engine. So alternator is an upgrade, 80 amps is an upgrade, and I've got them, and it's not going to cost me anything to use one. So therefore, use an 80 in my 120 project, even though this is much lower. It's just convenient to use that. Whereas I wanted that bit of extra pep for the 140, which is a bit more advanced electronically than a 120. So this guy's got 12 fuses. The whole 120 has 4 fuses for the entire car. So that kind of gives you an indication as to the complexity, and power requirements of a 140 versus a 120 Volvo. So thanks for hanging around. Hope that made some sense. That's a bit of electricity for you. The equation here is, in this case, so power equals volts multiplied by current, so let's call it amps. So watts, I don't think those are the correct letters, but so watts equals volts times amps. And what I've done here is rearrange that equation so that amps equals watts over volts. So if you put in your watts divided by volts, that's going to get you amps. And then the other one that you might want to use for something, I'm not too sure what you want to use it for, would be, we'll do it over here, would be, what do we got? So volts equals watts over amps. Amps. Yeah, fantastic. And that's how you can calculate it yourself, and spec a propose a sensible charging system for your car if you're modifying parts of the electrical system. And just make sure if you're bumping stuff up a whole lot, like 3 times bigger than your factory stuff, make sure your wiring's going to take it. It's a really good idea. And if you are chucking big stuff on like E-fans, probably use standalone wiring. Don't rely on the wiring that's doing this to do that, because it's just, you're going to run into dramas. You're going to burn wires, you're going to pop fuses, and you're not going to have a good time. So yeah, look after your earths, make sure you've got clean terminals, and you'll be right as rain.